Welcome to today's webinar, which is an introduction to T-Splines 3 for Rhino. My name is Matt Cederberg. I'm the CEO of T-Splines Inc., and it's my pleasure to be able to interact with you today and to host this webinar. I'm joined on the webinar with Kyle Houchins, a T-Splines trainer and the owner of the Outside Digital Art and Design Consultancy, where he uses T-Splines daily in his own design work. During today's webinar, I'll introduce T-Splines 3, and then Kyle will give a walkthrough. To start off, many of you are probably familiar with our company, but to formally introduce ourselves, T-Splines simplifies organic CAD modeling in Rhino and SolidWorks, making it easier, faster, and more fun. T-Splines gives a high-quality human feel to your designs, which nicely complements the exact engineering details that can be added with other software. T-Splines for Rhino helps you quickly create and edit organic models, ideal for anyone designing products that interface with humans, like consumer products, jewelry, toys, organic architecture. And to kind of start off the webinar, just to get a little bit of interaction going on, I'm just going to start a poll just to see who we can, who's actually on the webinar today. If you can just fill this in as far as which industry you are in, whether you're in jewelry, consumer products, architecture, or auto or transportation design, you can just give us a better feel of kind of who we're talking to, and Kyle can help tailor his demo accordingly. These are just some of the industries that we've seen T-Splines used in quite a bit, so just leave this poll open for another couple seconds. And let's go ahead and close this and see where we're at. So so looks like the main people we have today are jewelry and consumer products, along with some auto design and then a lot of other. So if anyone, yeah, so interesting to see that's the makeup. Just to introduce T-Splines more and what T-Splines is used for. First of all, it's used to create smooth, curvature continuous forms. In other software programs, it can take significant time before you can build up your surfaces to achieve a curvature continuous shape. With T-Splines, smoothness across the model comes by default because large portions of the model can be a single unified surface. This can be useful. Let's see, can you see my PowerPoint? Can you see that, Kyle?
Nope. I'm seeing the flash screen.
Let's check this
There
out.
we go.
Okay, thank you. This can be useful in a few situations. When you're modeling something like this chair, the smoothness and form is critical. However, smoothness is not always the only consideration. In the example of this airplane, the wings and tails need to be very accurate representations of airfoils, but the rest of the surfaces, the fuselages and other secondary structures, need to be very smooth and fair. Sky Greenwald, who designed this entire Formula One Rhino racer with T-Splines, so that iterating on his design with this T-Splines model takes about 75% less time than with NURBS. And if you'd like to hear details on this process, you can view a recorded webinar that Sky put on. You can just find that on our website. The second thing that T-Splines is used for is to help win more business with fewer iterations. Most designs, especially freeform designs, are not perfect after the first try. T-Splines lets you make lots of fast iterations, be more responsive to your clients, and win more business. Let's just go on to the next thing. T-Splines can help you win more work, can make your work more intuitive and fun. This is a comment that we get often from especially jewelers, that you can work with your T-Spline surfaces as if they were modeling clay. With a natural and fun interface, you can change the shape of the surface at will and it will never tear apart. And finally, T-Splines lets you design while you model. And you'll be seeing this a lot with Kyle's walkthrough today. Traditionally, when you design in Rhino, it's meant laying out curves that represent the critical shapes of your model, then creating surfaces from those curves, blending them together, then inevitably realizing that you'd like to tweak something. So you go back to the curves, make some changes, make the surfaces again, make sure your blends still work with the new surfaces, and then realize that you're closer, but you still want to make another tweak. And so you just kind of go around in that process. But with T-Splines, you can start by laying out curves and making a surface, but then Rather than returning back to the beginning of the process to make tweaks, you can actually explore design iterations by pushing and pulling the surface. This is a revolutionary way to model, and it's very effective, especially for organic forms. So you'll see Kyle doing that especially today. So a little bit of more information before I turn the time over to Kyle. This webinar is being recorded, and you will receive a link to the recording in a couple of days. And finally, we like these webinars to be interactive. We want you to get maximum value for taking time to watch this live instead of just watching a video. So please type in questions throughout the webinar in the box on the GoToWebinar panel on your screen. We have a support team here that will be typing back answers throughout the webinar, and then we'll also have some audible QA with Kyle at the end. So with that, let me turn the time over to Kyle Houchins. I guess one final thing before we turn the time over to Kyle. At the end of the webinar, we're going to do something that we have never actually done before with these webinars, and that's offer a coupon code for your purchase of T-Splines. So you'll want to check that out at the end of the webinar.
Hello, everybody. See my screen there, Matt?
Yeah, you're great.
Great. Okay. This is basically what we're going to be building today, and this is actually a very complex shape that we're going to build out of essentially 3 curves and about 2.5, maybe 3 tools. So this is going to be very much tailored towards kind of a beginner skill set, but the idea behind this is to show you how powerful this tool is with just a very limited amount of knowledge. Usually, when you're learning a piece of software, you get a little bit of information, and it just allows you to be dangerous. And T-Splines, a little bit of information allows you to be brilliant. So let's take a look at this shape right here and just analyze kind of what we're going to be building and talk about kind of the awesomeness that is here. Basically, we've got this chair, and there's a Y branch going into a Y branch, going into a Y branch, going in, and it's all blending seamlessly. And if I hide my isoparams, you can see that this thing is really, flowing quite nicely. And this was all accomplished using the pipe command, the extrude tool, a little bit of topology, futzing, which we'll go through, and then the symmetry tool, and it ends up with a shape that essentially is, I like to refer to these as kind of spandex models, because you can grab every aspect of this and mess with it to get a design that you're happy with. So it's easily updatable, and everything on it is easy to change. So let's go ahead and jump into this workflow here real quick, and let me change my viewport color here real quick, just so, because the preview for the pipe command is white, and I want you guys to be able to see that. So, so let's turn the curves on, and I'm going to shut my ground plane off, and let's talk a little bit about how this is made. And I'm going to delete those right here, and we'll just talk about the original input curves. And basically, if I look at this in the right-hand view, if it behaves itself, I've basically just got 2 curves laid out that represent the front and the back legs and the backrest of this, and then another curve that represents the leg. If we go to the top view, I've drawn another curve that represents the sweep or the shape that I want on the arm and the back curves. So the way that we're going to create these curves, this one's good just kind of as is, and that was just a simple curve that I just manipulated some of the CVs. If I look at this in the top view, basically it was just a planar curve. I grabbed a couple of the CVs and just bent them over a little bit. But let's talk about how we're creating the 3D curves here. And every time I teach a class, I'm a little bit surprised that nobody uses this tool. This was something, I went to CAR school, I went to Center for Creative Studies in their trans program, and this was something that we used all the time to create 3D curves. And that's curves from 2 directions. And you'll find that in the Rhino palette, underneath the fillet tool, there's a flyout, and there's an icon in here that's called curve from two views. And basically what this does is this projects this curve straight up, and this projects this curve straight over, and then creates a 3D intersection of that, giving you a 3D curve. So let's just go ahead and run that. And I'm going to pick this curve, and you'll notice that I get a resulting 3D curve there. And I'm going to pick this curve and this curve. I'm going to rerun that. First curve, second curve. And I'll get my second 3D curve, which means I can hide this stuff. And this is basically what I'm going to use to create this chair. Now, one thing to keep in mind, this is a projected curve, so if I turn on my points here, you're going to notice that there's a really high point count. Typical NURBS best practice modeling would insist that you rebuild these curves to a lower point count. Otherwise, you're going to end up with 1 billion isoparams on this, and that's typically a good idea when you're doing T-Splines objects as well, because T-Splines, if you take a NURBS object and convert it to a T-Splines object, it's going to inherit the patch structure from the original NURBS model. In this case, pipe gives us some controls that we don't really need to worry about that, but just keep in mind that if you're building something off of a NURBS surface, typically in T-Splines, you want to rebuild the curves, you want to rebuild the surfaces so that you have a good patch structure for all of that kind of stuff. Let me hide this for right now because we don't need to look at that. So let's jump right in and bring up the T-Splines interface, and I have a tab set up here where I have my T-Splines toolbar laid in there, and we're going to just go ahead and run this off the pipe command, which is here. It looks like a little squid. We're going to pick that. I'm going to just drag select both those curves and right click to accept, and you'll notice that I get this big fat chunky display. The first thing I want to do is change the radius on these curves because it's much too large. So I'm going to click the radius label up here, and I'm going to change this to, say, 0.1. Comes down to a much more reasonable size, but you notice that I've got a whole lot of sections going on here. And this is one of the cool things that pipe can do for you. And like I said, you don't necessarily have to rebuild the curve because pipe has some controls built in it. So let's do two things first. Let's look at the curve splitting. So I'm going to click curve splitting here, and I'm going to get some number icons showing up. And basically what these number icons are indicating is how many curves are coming together at each junction. And if I had one here, one here, one here, that makes sense. If I only had 2 here, or I had a 1 here, that would mean that the pipe command is not recognizing these curves as coincident, and I would need to change the tolerance to be looser. So say, for instance, these curves, if I back out of this, say, for instance, these curves were slightly apart. I can actually force the pipe command to recognize those as coincident by changing my tolerance. In this case, I'm going to have to do it, something ludicrous like 0.5. And you'll notice that it says, okay, this gap is close enough, so I'm gonna assume that those are coincident. Now that's an unreasonable gap and an unreasonable example, but I just wanted to show you how this particular part works. So let me back out of there, put it back where it came from. We'll rerun the pipe command. We'll check our curve splitting. We'll notice since we built it cleanly and we used snaps and all that kind of stuff that these are lining up. There's 3 sections right here, or 3 intersections right here as expected. We've got 1 on the corners, and that's okay. So we're going to right click to accept that. We're still in the tool. The next thing I want to do is change the segments because there's way too many segments here. If I were to accept this as it would be, there'd be a face for each one of these boxes. So let's click the segments label, and then I'm going to pick these indicator points, and I'm going to right-click to accept, telling it, yes, these are the indicator points that I want to modify. And you'll notice right now that the original number of segments is 23. I'm going to change that to 5, and you'll notice that I get a much simpler patch structure for the model. So I'm going to, still within the segments function, I can pick another point. I can right-click to say this is the point that I'm going to mess with. And you'll notice that there's 15 here. I'm going to change that to 8, so that's a little bit more manageable. I'm going to right-click to accept, and you'll notice that my new patch structure is much more reasonable and much easier to deal with. In fact, I may change that. Yeah, I'll change that a little bit lower, actually. I'm going to change that to 5. I can always go back and change it lower. So we're going to change that to 5. That's a really nice, simple representation of what's going on. My patch structure is going to be easy to deal with. I'm not going to have a whole lot of extra faces that I'm going to have to manage. And ideally, the model is going to end up being smoother overall. So let's adjust this a little further. And right now, everything's a consistent width. And so if I did this, it would just essentially be a plumbing pipe, and I don't want that. I'm going to change this to be thinner by clicking on this radius icon down here and then entering 0.05 as my units, essentially half of what my other pipes are, and it gives me a nice taper to this. The last thing I'm going to do is modify the joint and how this is blending in. And you'll notice if I zoom in on this, there's kind of a box-shaped joint right there. And the way that this is going to come together is not necessarily as elegant as I want. So what I'm going to do is I'm going to click this junction, and you'll notice that it cycles through a couple of different joint options. And in this case, I want the triangle pyramid because that's going to give me the cleanest Y-branching junction there. The last thing I'm going to do is change my output type to smooth, because when I right-click to accept this, I want it to just go ahead and make a smooth object. I'll right-click to accept, and you'll notice that I get a nice, smooth Y branch with a nice taper on it. I can shade this using the TS Shiny display, and you'll notice that I get a really gorgeous, beautifully branching curvature continuous model. Now, a few things about pipe that may not be originally apparent. It's history enabled, which means that as long as I don't mess with this surface, if I pick the surface and I move some points or I move an edge, the history is disturbed. If I don't do that, if I just pick the pipe command again and then pick the surface and right-click, it goes right back in. So after I've run the pipe command, I can take a look at this and say, you know what? That was a bonehead move making this 5. It really needed to be 8. I can always go back, change this to 8, or change it back to 5 because I really wanted it to be 5 in the first place. But I can go and adjust that. I can also adjust the radius on these things and make them bigger or smaller, however I want to do. Right-click to accept. The model updates. Now, the other thing is, if you had record history on, and I don't actually have record history on, so this is not going to work, but if I had record history on when I ran the command, I could go into my original curves, and I could pick my original curve, turn the points on for this curve, and I could actually move these points, and the pipe command would then change the shape of this to reflect the original curve. Now, typical kind of historical rules apply for when you're doing this kind of stuff. If you mess with the resulting surface, it breaks the history, and if you go back to the curve, they won't work. So you need to make all your adjustments. Kind of the hierarchy of your adjustments should be pick your curves, run the command, make your settings for the command, look at your output surface. If your original curves aren't right, go back to the original curve, modify the curve, the T-spline surface will update, and then you can make any further adjustments within the pipe command. Then start your modeling process where you're getting into making the rest of the part. Because the second I modify this, if I grab an edge here and move this, now my history is broken. If I go to run the pipe command again, no, actually it's not. Never mind. Give you bad info. Looks like you can modify the surface a little bit.
Yeah. No matter if you modify, you can always go back in and enter that command again. So.
Well, look at this. We're all learning today.
Yep. Yeah, and again, the purpose of that is, in this whole pipe command, is just to give you a really easy way to create branching shapes that where you don't have to spend your time worrying about the continuity.
So even if I modify this fairly severely, I can still go back into the command, and as long as I haven't extruded a face or something like that.
That's right. Yep.
Whee! Yay, that's cool. All right, look at us. We're all learning. All right. So the next part of this I want to build, I'm going to just pipe this command, this part of the leg using the same thing. I'm going to use it. Remembered what my last radius was, and that's a good thing because I want to use it. I do want to. I accepted that output and I didn't like it, so I'm going to go back and modify this. I'm going to drop this to 0.05 so that it's got a little bit of a taper to it. I'm going to change the segments on this to, from 28, I'm going to change that to, we'll say 8, so that gives me plenty of stuff to work with. And I'm going to go ahead and accept that, and you'll notice that I get my other leg. Now, believe it or not, we are about 70% done with this model right now. Basically, there's some very simple operations that are going to happen from here on out that are going to finish this model up, but most of the heavy lifting is already done. So let's go ahead and connect these guys up, and then we'll make the seat. And typically, when you're NURBS modeling, this is where the beads of sweat start forming on your forehead, and you start saying, "Oh boy, now I got to blend this thing into this, and it's never gonna, it's never gonna be curvature, and it's gonna, have a big dink in it, and I'm gonna have to, sand this out after I get the prototype." Well, the beauty of T-Splines is most of the work goes into laying out the primary surfaces, and when you get to the point where you're starting to do your transitions, T-Splines kind of does that stuff for you for free. So let's go ahead and just bridge this. I'm going to use face mode, and I'm going to bridge from here to here, and I want to take a look at this icon a little bit and make sure that my bridge is happening how I want it to happen. So I've got 4 points that represent the 4 corners of this blend. And basically it looks like it's making the right assumption because I want to have this lower corner connect to this lower corner. If for some reason it was indicating this, then it would be telling me that this corner is going to attach to this corner. And I don't want that. So all you have to do to change it is pick the point, and the icon updates. Now, there's also a direction indicator here, and so the first time you click the corner, it's going to tell you this is the corner that you're connecting to, but you want to make sure that your direction is going the same way. And in this case, my direction is going this way on this surface, and it's going this way on this surface, which is going to result in a twisted 180 blend. So all I need to do is click that point again. Now my curves are going in the right direction. I right-click to accept, and I get this awesome curvature blend. And if I shade that without the isoparams, you'll notice that it's blending in really beautifully. Take that, NURBS. So I'm going to adjust this just a hair. I'm going to grab an edge here, and I'm going to slide this back. And again, since I have this beautiful kind of spandex liquid model, I can just pull this around. We can update that, and you'll notice that my transition is just drop dead gorgeous. If you are a highlight nerd like I am, TS Shiny and T-Splines are going to eat up hours of your life because you'll just be sitting there spinning it and spinning it and spinning it. So let's adjust this a little bit more, and let's go ahead and make the seat. It doesn't really matter kind of what order we do this in, but, well, let's go ahead and make the branch first. So I'm going to blend from this face here down into the edge here to make a support, because right now this thing is all cantilevered back, and if a typical American were to sit in it, it would snap off and send them flying off into space. So let's bridge this, and we're going to use face mode again, and I'm going to bridge from this face, and we'll just try and see what it looks like with this one. And I'm going to use more than one segment this time. I'm going to change this to 3 by clicking on the segments label and entering 3. I want to check to see my alignment, and right now this is a perfect example of the fact that this alignment is going to result in a really bizarre surface because this one is blending from this corner in this direction, and this one's blending from this corner in this direction. So I'm going to change that by clicking here, and the direction is wrong, so I'm going to click it again and change the direction. Now we're both going in the right direction. I'm going to right click to accept that, and it's going to just slap another row of surfaces in here that I can go and adjust. I'm going to pick that edge loop, and I'm just going to scale it a little bit and start playing with the shape. And going back to what Matt said, you know, one of the real beauties of the software is the fact that I started with a couple of original curves and kind of an idea, and then as I'm going, I can update that idea based on the 3D information that I'm getting and make my design decisions on the fly here to really work a design into something that may be a little different than what I was originally thinking. And the discovery process, as far as, you know, designing something is really part of it, and this tool allows you to iterate and discover and experiment, you know, so quickly, essentially in real time, that I find it to be a really, really liberating way to work. And a lot of times I've kind of foregone the typical design process, which is, you know, do a sketch, do control art, bring the control art into a modeling program, try to model it exactly like the control art, and this, that, and the other thing. I'll start literally with kind of a gesture sketch. I'll throw it in there, and I'll start throwing T-spline surfaces at it. Then I'll get rid of the gesture sketch completely because really, at the end of the day, the 3D object that you're creating is the most important aspect of the entire design. So why not make your design decisions in 3D where you can see them and evaluate them in a real-world kind of environment, as opposed to sitting there like a CAD monkey trying to match a drawing. No offense to CAD monkeys. So let's go ahead and make the seat on this, and this is a really simple process of grabbing some faces here, and I'm going to grab these, and we'll roll that seat down that far, that'll work. And I'm going to just bring up my translate manipulator here out of my heads-up display by hitting the W key for the hotkey or clicking through here in the heads-up display. And I'm going to hold down the Alt key and drag on the X direction, and it's going to extrude an additional set of faces. We always joke that holding down the Alt key is German for add geometry, and then I had a class with a guy who was German who said, no, it's not. And so no, it's not. It's not really German for add geometry, but we just use that as a joke. Whereas if I were to just pull on this, it moves. If I Alt pull on it, then it actually adds a row in here, and it gives me some additional stuff to work with. So I'm going to just grab these edge loops and slide them around a little bit to something that feels right. And a trick that my business partner Kevin Pasco showed me from his polymodeling days is actually, if you notice, this isoparam is a little bit tweaky. It's not quite straight. If I pick that entire loop and bring up the scale manipulator and scale it in the X direction, you'll notice that since the scale manipulator is centered in the bounding box of that isoparam, I can use that to actually straighten it out. And so I'm just going to do that here, and I'm going to do that here, and you'll notice that those just kind of come into line. And this is a really good trick if you have done a lot of modeling and you find out that, you know, you've got some wavy points or some wavy isoparams or something like that that you want to straighten out. So at this point, you know, we've got pretty much our chair built, and if I throw the shiny back on this that we all love so much and take a look at it, you'll notice that there's not a kink or a dent to be found. And again, we've got a Y branch going into a Y branch, going into a Y branch, going into a Y branch, going into a Y branch. I dare you to build that in NURBS. I know it can be done, but not in 14 minutes. So the last thing that we need to do is flip this and get the other half of the chair and then make our final adjustments. So what I'm going to do before I apply symmetry to this model is I'm going to open up these three edges here. And the way I'm going to do that is just by picking these faces. And I'm going to pick that face and that face. And if I delete them, I'm getting rid of the three-dimensional information that allows T-Splines to create the blend, and it just assumes that this is a oops, I got a second face in there. This one, that, and that one. Not the second one. So T-Splines just opens that up and leaves that edge flat. And if I look at this from the top view, you'll notice that none of this stuff is lined up. So I'm just going to pick these edges. I'm going to hit the L key, which is the loop select, and that's going to make sure that I pick all of the edges that are aligned there. And then I'm going to just use a Rhino command, and if I hover over the command line, it temporarily disables the T-Splines hotkeys. And I'm just going to run the Rhino set point command. And I want to set those in the X, so I'm going to shut these two off. And I'm going to just type 0 so that I know that those are locked in to the origin. Go back to my T-Splines tab, and then let's throw a little symmetry on this. Pick the symmetry tool, pick the object. I'm going to just pick a point here and pick a point here. T-Splines is going to think for a second, and then it's going to throw this in symmetry. Now, the chair is a little wide, and there's also a little kind of gank going on in this transition here. So I'm going to straighten that out just by simply drag selecting these edges right here because they're fairly close. And I'm just going to delete them. And since we have some symmetry enabled, it's going to delete these edges and these edges. And if we go back to the top view, you'll notice that that smooths out dramatically. Now, I want to talk for just a second about why that worked, and I'm sure a lot of you already understand why that did what it did. But if we look at a typical NURBS curve, and I were to make essentially the scenario that I had before, and I turn on my points, you'll notice that I've got, let's just say, an edge, and then the old edge that I deleted here, and an edge here. Now, with a NURBS curve, as I move these points closer or farther together, my NURBS curve tightens up or loosens up depending on how far these points are away. Think about everything that you already know about building nice clean NURBS curves and translate that into your T-Splines practice, and the fact that if you want to make a sharp edge, you need to have points closer together, right? If you need to have a nice soft edge, then you need to have points farther apart. In T-Splines, you do the exact same thing. This transition right here is a little bit tight, but look at how close these edges are. So I'm going to just grab these two edges, and I'm just going to move those around a little bit until they are a little farther apart, spaced a little more naturally, and allow T-Splines to make that transition a little bit smoother. You can do that on the points, you can do that on the faces, you can do that on the edges. In this case, I was doing it on the points, but you can do the same thing on the edges just by selecting those and moving them around. You can also affect how that transition comes in or out depending on where you position those in space. And it's the exact same thing that you know about NURBS curves as far as positioning a point on a curve. Okay. So let's go back to the perspective view and take a look at this. It's a little bit wide, so I'm just going to pick it using object mode or hitting the F key on the keyboard. I'm going to bring up my scale manipulator, and I'm just going to scale this in 1D. I'll bring it in globally and make it much more chair-like. Now, the cool thing about this is if you were designing a chair that had to stack, for instance, you could take this chair and cut and paste it and experiment with how this model were to stack. And I could see in this case that it wouldn't work in its current standpoint. So what I would have to do then is lock one and then start playing with this thing in order to see what I need to do in order to get it to stack. And in this case, I'd probably need to come in and I need to bend the legs so that they come in a little bit more, and I need to bend the back so that it, tapers a little bit and all that kind of stuff. But this is all really easy to do because obviously every part of the model is super easy to modify. So if I needed to taper this edge, I just pull this in, and I can see that it updates symmetrically because we have that aligned, and then I could go back and do the stacking experiment and see how it would work out. So instead of having a NURBS model that you'd have to take apart and redo all your blends and all that kind of stuff, you've got this kind of, like I like to say, kind of spandex model that you can just play with until you get what you want. Designing in 3D instead of building in 3D. And also, if you wanted to do a family of shapes, if this was a chair and a bench, you just made a couple of $1,000 an hour right there because you just went from a chair to a bench. All of your transitions happen beautifully. You've got a great family look. Obviously, you go in and adjust some of this stuff, but it really is that easy. So as far as iteration and exploration and all that kind of stuff, it's hands down, it's like bringing a cannon to a noodle fight. As far as this tool is concerned, as far as productivity. So that's pretty much what I wanted to show you today. If there's any questions, please hit us up, and we'll do the best we can to try and answer any questions that you have real time. And one of the cool things about attending the webinars as opposed to watching them recorded is if there's something on this that doesn't make sense, we can go ahead and address it real time, and I'll get something out of it. So go ahead and hit me with what you got, and if there isn't any questions, then we'll go ahead and wrap up.
Okay, well let me, before we turn the time over to Kyle for questions, and we do have a few coming in, let me just say thanks everyone for coming to the webinar. We hope that's this has been time well spent for you. As you leave, we'll pop up a survey when you close out of the webinar, and if you could just answer those questions, that will help us make even better webinars in the future. And also, just as a way of saying thank you, this is something that I don't believe we've ever done actually with one of these webinars, is offer a coupon. You can save an extra $50 when you buy T-Splines during the next week. So the coupon code in honor of the presenter today is Kyle. So if you just go to the T-Splines webpage and buy a T-Splines commercial or a floating license, or any of the bundles that include T-Splines commercial licenses, then you can get an extra $50 off during the next week. So with that, let me make Kyle back to the presenter, and there's a few questions that came in. So one question is, when you are doing that scaling, Kyle, doesn't that change the radius of the pipes, and is there anything you can do to keep that radius?
Well, ideally, what you would do if you had to, yes, it does, because it's obviously a 1D scale. So it's scaling from the center. The farther away you get from the center, the bigger this stuff is going to get. There's two ways to deal with it. One would be to come in here and individually, scale these back to what you wanted. Or quite honestly, this process is so quick that I would go back and scale my original curves, rebuild the model, repipe this part of the model, delete the back, delete the sides, repipe this, and then just rebuild the bridge over here. So you're talking about, I mean, I'm lazy, but this is only like 4 button clicks to redo this. So, you could very quickly go through and rebuild this model, in a really short amount of time with the, pretty much the exact same curve set. So, if I was going to build this, in my own business, if I was going to build this for a client and they needed to have a line, I'd start with my original curves. Oops. I'd start with my original curves, and then I'd do chair width, I'd do bench width, I'd do, a bar stool without a back, I'd do, and I would set up all my original curves, and then I would just build them using the same process one after the other.
Yeah, and the other thing that you can do as well is if you just select most of the faces, Kyle, and just translate them instead of scale,
Yeah,
then
absolutely.
maybe you could show how that works as well. Because again, the whole T-spline, it's this big, flexible, unified surface, and so you can grab different faces and pull them out, and it won't break the surface at all.
So if I grab these, and instead of scaling, if I were to just translate them, I can just stretch this into a bench,
And that would keep the same radii on the sides.
diameter. Yeah.
Let's see. So here's a question that came a while back. Can you add in a surface with hard corners?
Yeah, you can always throw some creases in this, but the creases are going to translate through your model. So in this particular design, I wasn't really thinking hard corners on this, but yeah, you can crease certain parts of it. Like, say, for instance, if we wanted to sharpen up the edge of this, I could pick an edge here and an edge here, and then I could throw a crease on that, and the crease, once it throws in there, is going to start nice and hard, and then it's going to translate 2 faces, and then it's just going to fade right out. So you notice that we get a nice sharp edge here, and then it fades out back into G2 here. And that happens over 2 faces. So you'll notice I just creased this edge, and this is a full crease. So if you look at this mathematically and say, okay, this is 1 and this is 1, which is representing full crease, here we've got 1 and 0.5, and then here we have 0.5 and 0. So this is going to start creasing, it's going to start fading out, and then by the time it gets here, it's going to be gone. So
Yeah,
if I were to crease this one and this one, I'd need to have 2 edges here and stuff like that. So
yeah, and we
sorry,
put on a webinar, yeah, and we can send a link to this as well. We did a webinar a while ago about advanced T-splines modeling that talks about all the details and the math behind the creases and stuff like that we can send a link to as well. It might be useful as well, Kyle, to show how you can convert from T-splines to NURBS and then add sharp parts to the model through Booleans or something like that.
Oh, I don't know if we have enough time to convert to NURBS, man. If I wanted to convert this to NURBS, it's a single button click. So if I go up here, there's a convert to T-splines under the left click. There's a convert to NURBS under the right click. So if I right click this and pick my model, now this is, you'll notice up here in the heads-up display, it's just a watertight poly surface. And if I'm completely out of T-splines at this point, and this is just a NURBS poly surface. If I look at this just to prove that I'm not lying to you, if I right-click this, you'll notice that it's got 100 edges. None of them are naked. None of them are non-manifold, which means this is a bulletproof NURBS model. This will go to Pro-E. This will go to SolidWorks. This will go to Rapid Prototype, and this will go to CNC all day long. We do it here all the time. So if I wanted to add some hard edge features to this, like say for instance I wanted to, add some drain holes here or something like that, I could just pick these. By the way, Rhino has a new gumball feature, and I just discovered this actually. One of the Rhino guys told me about this. If I hold the Shift key and drag on a Rhino manipulator, it extrudes the surface.
This is in Rhino 5 beta, right?
This is Rhino 5, which is remarkably T-Splines-like. Imitation is the most sincere form of flattery. So now we can get some hard shapes through here, and since the fidelity on this data is so good, we can throw fillets and stuff like this all day long, and it works quite well. So that would be kind of my thought as to if I were going to need hard edge stuff. Keep in mind T-Splines is an organic modeling plugin for Rhino. So organic modeling tells me that it's best suited for making swoopy shapes that blend into each other. Rhino, on the other hand, is a really good hard surface modeler. So make sure that you're not pounding in screws with a hammer here and trying to make hard edge stuff in T-Splines. If you need hard edge stuff, use Rhino because Rhino is awesome at that. If you need swoopy organic stuff, use T-Splines because T-Splines is awesome at that. And then that way you're using the right tool for the right job as opposed to trying to force one thing to do something when the other thing's better at it. So, any other questions?
Let's see. Let's see. Here's just a question that just came in. I added 2 points to a model in the middle of 2 lines. I wanted to massage the surface by pulling those 2 points, and it worked great. Is that an okay technique to use?
It works great for you. It works great for us. So yes, you can. You can do that. Matt, is there any downside to just throwing a point in the surface and pulling it?
No. Yeah. Why don't you undo? Why don't you go back to just the T-spline model? And this is a great point that Lee brings up. We haven't talked a lot about some of the technical things of T-splines, but one of those is that you can add just even single points in the model wherever you want to get more detail. So if you just add, maybe in the seat somewhere, Kyle, just use the insert point command and just add a point on either side of, and then and when Kyle moves this point after it's been added, then the surface will maintain curvature continuity where he moves that. So yeah, so that's a great way to use T-splines.
So you'll notice that I inserted that point, and I inserted it simple, so T-splines adjusted a little bit around that. But this point is here. Get out of the Rhino gumball there, and I can pull that and actually have an additional area where I can adjust that model. And if I adjust that model and decide I don't like that, I can obviously delete that point just like I could with an edge or a face, and it's going to go away and come right back into there. So, typically in my own practice, and I'm an admitted Neanderthal when it comes to this stuff. I always look for the cinder block simple, anvil approach, and so I tend not to do anything terribly fancy. And so when I'm doing something like that, I'll typically just add an edge through here, and in my tiny Neanderthal brain, that makes more sense to me because it's a little bit easier to organize. But if you're one of these people who can keep track of stuff kind of thrown all around the model, then knock yourself out. However you want to work, T-Splines is flexible enough to accommodate. So whatever works for you, go for it.
Let's see. Here's another question that's come in, and just before we bring that up, we do have about 5 minutes left. So if you are working through the T-Splines trial and you have any questions at all, about any of the commands on the software, this is really your time to ask those, and we'd love to answer them. Our goal is just to help shorten the learning curve as much as we can, so nothing's off limit as far as questions you're running into as you're working through T-Splines. So someone's asking, at this point, Kyle, can you come in and change the radius that you did with the pipe command? I believe the answer is no at this point, because you've gone ahead and added the extrusions, and it's no longer just the original pipe curves. Yeah, and you can see, yeah, at this point, yeah, you aren't able to do that.
Yeah.
But yeah, as long as you just have the original pipe curves, you can go ahead and change the radius.
Yeah.
Here's another question: are there going to be more webinars? We probably on average we do 1 or 2 webinars a month. As you leave this webinar, one of the questions that we ask is if you'd like to be notified of future webinars, and if you mark that, then we'll send you emails. We also advertise these on Facebook and in our forums. The next webinar that we have scheduled next month is actually all about the T-Splines pipe command. So this is the command that Kyle used to start out this bench, but it's an extremely powerful command, and that's what the next webinar will be focused on.
Any other questions?
Okay, looks like a final question just about whether this webinar will be available later online. Yeah, it will be recorded, and it will just be on our T-Splines webinars page. There's a question, is there a T-Splines book with these exercises? We have a T-Splines user manual, and you can download that at tsplines.com/user manual, and so that's helpful. We also offer live T-Splines training classes. We just did one in Chicago last week. There's one in Irvine, California coming up, in London next month, and then also what we're going to do is with those live training classes, we have about a series of 15 models similar to this chair that we work through to introduce you to T-Splines in a methodical way, and we're just starting the process of making videos of all that live training and making those available with the files online. So if that's something that you're interested in, you can respond to the follow-up email from this webinar, and we'll make sure that we notify you about that as soon as that goes live. Question: is there a newsletter? Yes, there is a T-Splines newsletter, and we'll get you information about how to get on that as well with a follow-up email. Another question: how about some jewelry models? What do you say to that, Kyle?
Yeah, that sounds great. Just as a side note, pipe is amazing for jewelry stuff, because not only can you use curves and let pipe do all your transitions between the curves, so if you're doing filigree or stuff that's overlapping like that, it's a piece of cake to do it with the pipe command. But you can also take the resultant piped T-spline surface and flow it along a curve, and using the Rhino UDT tools, as long as you put the UDT on the points, throw the UDT on the T-splines in points mode, and you can actually take an object, run the pipe command, and then flow that resultant surface along a curve, flow it along a surface, bend it, twist it, all that kind of stuff, using the Rhino UDT tools, which is just, as far as jewelry is concerned, is an absolute killer app. So I believe there is a recorded, correct me if I'm wrong here, Matt, didn't we do the heart ring at one point?
Yeah, we've done a couple webinars with jewelry. We did one with Travis Serio, who won the Lost Modeling Contest with a piece of jewelry. Mm-hmm. So.
Yeah. If you want to see a jewelry webinar, watch Travis's, because Travis is a jeweler and I'm a monkey. So you want to go to that guy for jewelry advice. But we would certainly be open to putting something like that back.
So here's just a good comment from Lee. He says, as an old solid modeler, my biggest problem is that T-Splines is too easy. I can't stop myself from overcomplicating everything. Um, Kyle, can you talk to that as far as your experience learning T-Splines?
Yeah, Lee, I'm right there with you, man. I had a really kind of bumpy learning curve with T-Splines. I alluded to my business partner Kevin Pasco before, was a video game guy for years, and he did a lot of poly modeling in Studio Max, and he was the one who kind of clicked the light bulb on in my head as far as how this stuff works. And in T-Splines, if you think about if all you got, like, go back to art school and think about, like, that one annoying conceptual teacher you had who said, okay, we're going to make a 3D model of Michelangelo's David, and all you get to use are Post-it notes. Well, in T-Splines, that's actually kind of how you do stuff. If you imagine that someone gave you a giant stack of Post-it notes that are all the same size, and you built your model out of little squares of paper, that's how you actually build stuff in T-Splines. And so for me, there was kind of a conceptual hurdle because I kept saying, well, geez, where's the trim tool? Where's the fillet tool? Where's the this? Where's the that? And in T-Splines, it's basically you build your main shapes and then let T-Splines do the transitions for you. Where in NURBS, the whole idea is getting to the point where you can implicitly build your transitions. That's where the sweat, like I said, the beads of sweat start rolling down your forehead, getting those transitions to happen. In T-Splines, all you have to do is block out your main forms and then let T-Splines do your transitions, either using the bridge tool or welding or whatever you want to do, and that's where T-Splines math kicks in and you get these beautiful transitions. So the thing that I tell everybody when they take the class, there's an old joke in guys who are into old cars about Colin Chapman from Lotus Cars, and they said that one of the reasons that his cars were so light is he used to take the chassis and he'd build it, and then he'd start removing pieces until the chassis collapsed under its own weight, and then he would put that one piece back in, and that was the design. And I think there's, as tongue-in-cheek as that is, I think there's some wisdom there when it comes to T-Splines modeling. If you find yourself going down the road and the thing just keeps getting more and more complicated, stop yourself, start deleting stuff until the model falls apart, and then undo the last thing you deleted, and you're probably going to be about where you need to be. So, a perfect example is this back here. I've got 1, 2, 3, 4, 5 edges that make up this back. I could probably get away with getting rid of these 2 edges and these 2 edges, and just carefully positioning this corner in order to actually get a better sweep out of this, as opposed to the added complication of this. Same thing with this bench seat. I probably only need this edge, the center line, and this edge. I probably don't even need this row of edges, so I can go ahead and delete those because they're unnecessary and they're just added complication. So I would encourage you, as you're doing this, to go through the model and try pulling stuff out until the model blows up on you, and then undo the last thing you did, and you're probably going to be in good shape.
Okay, looks like just one final question / comment. Can we do any more automotive slanted webinars? I think there was one a while back. Yeah, we did do an automotive webinar about a little over a year ago. You can find that on our website. But what do you think, Kyle? Kyle models toy cars almost all day long with T-Splines.
Yeah, I'd love to. I'm actually in the process of working on a good workflow for doing that. Cars are inherently, brutally complicated objects, and to try and fit a car build into a cohesive hour is a challenge, to say the least. So yes, it's definitely something that we're trying to put together, but I'm trying to figure out the best way to present that in a way that isn't just absolute massive blathering overload when we present it. So we've talked about the possibility of maybe doing it in a couple of pieces, like maybe it's a 3-part webinar and we do the first part and then the second one and then the third one over a couple of weeks. But if you have any ideas, as how you would want to see that or what particular aspects of automotive modeling that you're interested in, we could certainly go from there. The 2 that are on the web right now, I believe, Matt, we have the bumper
Yep.
recorded, and then the hood on that Buick hood scoop is recorded. So yeah, I'm a car geek by definition, and so anytime I can throw car stuff at people, I'm totally down with that. The challenge is just trying to figure out how to do it so that it's not, just massively overloaded, because it gets to the point where it's not helpful anymore. So.
Okay. Well, good. Well, thanks everyone for taking time today. We really appreciate it, and we'll let you get on with your day. And you can look for a follow-up email from us with more information soon. And again, just to say thanks for spending the hour with us. If you go ahead and buy T-Splines in the next week and use the coupon code Kyle, K-Y-L-E, that'll get you $50 off. So thanks again for coming. Talk to you later.
If you use Kyle is awesome, Matt will give you $100 off.
All right. See y'all later.
Bye. Thank you.